Hey guys, I am making this video because I don't mind meeting on Google Meet, but I couldn't figure out on Friday how to record when we were on Google Meet. And so then I felt bad for people who might need to watch this video because they're at home and not at school, or just if you guys need to watch it again. So going ahead and making this video. We're moving on to the next section today. We're in section 1.3 and we're going to be solving linear equations. So this should be a pretty good review from Algebra 1. Really not learning anything new, just kind of brushing up on those skills that maybe we haven't used in a while. Remember that an equation has to have an equal sign. That's what makes it an equation. And we are focusing in this chapter just on linear equations. In other words, if we were to graph them, we would get a line. And so we're going to have a variable. We're not going to have any variables that are raised to an exponent of 2 or higher. Everything would just have an exponent of a 1. Now, when we see a variable like x or y, we don't see that exponent there. It's understood to be there. So you might not see that exponent of 1, but it's there. If we were to graph it, we would get a line. That's what we're focusing on in chapter 1, are just linear equations. So remember, back in pre-algebra and in algebra 1, when you learned how to solve an equation, the goal is always to get the variable by itself. And there's a couple of steps, and these aren't on your paper. I'm just going to say these out loud to refresh your memory. If there are grouping symbols, parentheses, brackets, we want to try to get rid of those first. We want to see if there are any like terms. So if there are, we want to combine those. If we see addition or subtraction, we want to undo it using the opposite operation. In other words, if I see subtraction, I'm going to do addition. Or if I see addition, I'm going to do subtraction, because those two operations, they undo one another. And then usually the last step is if you see multiplication or division, you want to undo it. So if I see multiplication, I'm going to divide. If I see division, I'm going to multiply. So we're going to start off real easy. Example number 1 has x plus 9 equals 15. So the goal is to get x by itself. Drawing a line right here. You don't have to do that on your paper, but for some people, they like a visual to see what I mean when I'm talking about both sides of an equation. So our goal is to get x by itself. And what I see happening between the x and the 9 is addition. So the opposite of addition is subtraction. So I'm going to subtract 9. Golden rule in math, whatever you do to one side, you have to do to the other. So I'm going to subtract 9 from both sides. Over here on the left, this plus 9 and this minus 9, they cancel each other out. Remember, I called those inverse operations. I bring the x down. I bring the equal sign down. And then over here on the right side, 15 minus 9 is 6. And x is by itself, and that's how I know I'm done. X equals 6 is our solution. Number 2, I want to get y by itself. The y is joined with the negative 3 for multiplication. So when you don't see an operation symbol there, if you just see a number and it looks like it's just attached to a variable, that is multiplication. So the opposite of multiplication is division. So I'm going to divide both sides by negative 3. So those negative 3's right there, they cancel each other out. Leaves me with a y. Bring down my equal sign. And then 36 divided by negative 3 is negative 12. And that's my solution. Y equals negative 12. All right, number 3. I want to solve for n. Here's the problem. There are n's on both the left and the right side of the equal sign. So a good rule of thumb is to move the smaller one. Now, you don't have to do it that way. You can move the bigger one. We could have people in this class doing it different ways, and we can still come up with the same solution. I just prefer, my preference is to move the smaller one. So I have a 12n and a 4n. Obviously, 4n is smaller, so I'm going to move that one. Now, because that's a positive 4n, the only way I can get rid of it is to have a negative 4n, which is like subtraction, right? So I am subtracting 4n from both sides. So over here on the right-hand side, those are going to cancel out. 12n minus 4n leaves us with 8n. Then I'm going to bring down the minus 3. I'm going to bring down the equal sign. And then on the other side, I'm going to bring down that positive 21. So for this problem, the very first thing I had to do was get the variables all on one side. Now I'm looking for addition or subtraction. I see subtraction, so I'm going to do the opposite, which is addition. I'm going to add 3 to each side. So I've got 8n equals 24. I'm almost done. I see 8 and the n joined together by multiplication. So again, the opposite of that is division. I'm going to divide both sides by 8, and I'm going to be left with n equals 3. All right, hopefully we're feeling pretty good so far. Those are some basic problems from pre-algebra. So number 4, we've got some grouping symbols. Now grouping symbols just means we'll probably have the distributive property. So if we take a look at the left side of the equation, this 5 is going to be distributed to the m and to the minus 2. So 5 times m is 5m minus 5 times 2 is 10. So I get 5m minus 10. Then I bring down the equal sign. On the other side, we're going to distribute. This time we're distributing a negative 4. So negative 4 times 2m is negative 8, plus negative 4 times 7 is a negative 28. So you can write, if you want, you can write plus negative 28, or you can just write minus 28. Those two things are equivalent. They mean the same thing. And then behind it, we're going to continue to bring down the plus m. Notice we did not distribute that negative 4 to the m because it was not inside the parentheses. So I've done the distributive property, but what I notice very quickly is that on the right-hand side, I have some like terms. So before I do anything else, I'm going to leave the left side the same, and I'm going to combine those like terms over there. So a negative 8m and a positive 1m, if I add those two numbers together, negative 8 plus 1 is negative 7. So I have negative 7m left, and then I'm going to bring down that minus 28. So when they are on the same side, you do not do opposite operations. You do what you see. I saw negative 8 plus 1. That's how I got the negative 7. If they're on the same side, do not do opposite operations. All right. Now I want to get the variables on the same side. Remember, I told y'all my preference is to move the smaller one, which would be the negative 7m. So the opposite of that is a positive. So I'm going to put plus 7m on each side. It's going to cancel those out over there on the right-hand side. On the left-hand side, 5m plus 7m is 12m. Bring down the minus 10. Bring down the equal sign. On the other side, important to note, I'm not just bringing down that 28. I have to bring down that sign that's right in front of it. So that makes that a negative 28. So you got to pay attention to the sign that comes right in front of it. It's attached to the 28. Now I want to look for addition or subtraction. We've got subtraction happening over here on the left, so I'm going to undo that using addition. So those 10s are going to cancel out. I now have 12m equals negative 28 plus 10 is negative 18. The last thing I see is that I have multiplication happening, so I'm going to choose to divide. I'm going to divide both sides by 12. All right, here's what I know. I know that 12 is not going to evenly go into negative 18. So you have two options. You can divide this and turn it into a decimal, or you can just reduce it and leave it in the form of a fraction. I personally like fractions. That's what I'm going to do. I know that both of those numbers are both divisible by 6. So negative 18 divided by 6 is negative 3, and 12 divided by 6 is 2. So my answer is m equals negative 3/2. If you changed it to a decimal, you would get negative 1.5, and both of those answers would be correct. So whichever one you prefer, fractions or decimals, is fine with me. So remember those steps. We're going to look for grouping symbols, and that usually means we're going to have to do the distributive property. We want to combine like terms if there are any. If we have variables on both sides, we need to move them so that we only have them on one side. Remember, my preference is I like to move the smaller one. Then we want to undo any addition or subtraction that we see. And then last, we want to undo any multiplication or division that we see. All right, so number 5 is a lot like the last one we just did. We're going to have some grouping symbols, so we're going to distribute. So over here, I'm going to distribute the 6. So 6 times 3 is 18, minus 6 times d is 6d. On the right-hand side, I'm going to distribute a negative 5. Negative 5 times 2d is negative 10d. A negative 5 times a positive 9 is a negative 45. And then I continue to have the plus 18. So again, I notice I have like terms. I have the negative 45, which is a constant. Remember, that means it doesn't have a variable. I have the plus 18, which is also another constant. So we're going to combine those together. Everything else is staying as is for the moment. So we're going to do negative 45 plus 18, and that's going to leave me with a negative 37. All right, I noticed that I have variables on both sides. So if you think about the minus sign as a negative sign, I have a negative 6d on the left. I have a negative 10d on the right. Negative 10 is smaller than negative 6, so that's the one I'm going to choose to move. And the opposite of a negative 10d is a positive 10d. So I'm adding 10d to each side. So I'm bringing down that 18. Negative 6 plus 10 is going to leave me with a positive 4d, bringing down the equal sign. On the other side, the d's have canceled. I'm going to bring down not just a 37, but a negative 37 because it had the minus sign in front of it. All right, next I want to get rid of the 18. I need the opposite of that positive 18, so that's going to be a negative 18. So I'm minusing 18 from each side. Bring down that positive 4d, bring down the equal sign. Negative 37 minus 18, again, that's the same thing as negative 37 plus negative 18. So I'm adding two negative numbers, and I end up getting negative 55. And now I want to divide each side by 4 because I see multiplication, so I got to do the opposite of that. Now 4 is not going to go into negative 55 evenly. And matter of fact, it actually doesn't reduce because neither of those numbers have anything in common. So I'm going to leave it as negative 55 over 4. If you wanted, you could change that to a fraction. I will leave that up to you. I believe it would be negative 13.75 if I'm not mistaken. All right, number 6. I see grouping symbols again. Now if we take a look at the left-hand side, I see what looks like a negative or a minus sign in front of the parentheses, and I don't actually see a number with it. That is understood to be a negative 1. You don't have to write that on your paper if you're comfortable with it as a negative sign, but I know some students kind of have a hard time with that not having a number. So if you feel the need to write that there, it's fine. I'm going to distribute that as a negative 1. So negative 1 times g is negative 1g. And negative 1 times positive 2 is a negative 2. Then I'm going to bring down the minus 2g and the equal sign. And now on the other side, I'm going to distribute a negative 2. Negative 2 times g is negative 2g. Negative 2 times 1 is negative 2. Now the right-hand side over here doesn't have any like terms because this has a variable and this one does not. But over on the left-hand side, I do have like terms. I have a negative 1g, I have a negative 2g. So if I combine those together, negative 1 plus negative 2, I'm going to get a negative 3g. And then I'm going to continue to keep that minus 2. On the other side hasn't changed. All right, so I have variables on both sides. I want to get them on one side. So remember, I want to move the smaller one. Negative 3 is smaller than negative 2, so I'm going to move that one, which means I'm going to add, so plus 3g on each side. I'm going to bring down this negative 2, bring down the equal sign. On the right hand side, negative 2g plus 3g is going to leave me with a 1g. And again, if you feel like you want to put the number in front, you can. It's not necessary. It's like saying I have a pen. I didn't say I had one pen, but you understand that it's one pen. So if I just write a G, it's understood to be just one. And then I'm going to bring down that minus 2. So I'm almost done. I need to get G by itself, which means I need to get rid of this minus 2. So the opposite of a minus 2 is a plus 2. So I'm going to add 2. So those are gone. So on the right hand side, I still have the G, bring down the equal sign. Over here, negative 2 plus 2, those things cancel out and they turn into 0. And so my answer is that G equals 0. All right, let's take a look at number 7. Now there's some fractions in the next couple problems, and I know usually students groan when they see fractions, so you guys might be groaning right now, and I just can't hear you. I'm going to show you what I think is going to be an easy way for you to do these problems. So my suggestion, if you don't like fractions, is to get rid of it. How do we do that? Well, I would look and say, okay, in number 7, there's only one denominator. It's that 2 right there. It's the only one. So I am going to multiply both sides of the equation by 2. Now in doing that, notice I put parentheses there. I'm going to have to do the distributive property. So I'm going to do this. So let me write this step down just so you can kind of see what's going on. I'm going to write it over here because I don't know if I would end up with enough space over here. If I did 2 times 7 over 2, here's what I want you to notice. I'm going to put this 2 over a 1. This 2 that's in the denominator and this 2 that's in the numerator, they are going to cancel each other out. That's actually why I wanted to multiply both sides by 2, because now I'm just left with 7. So this is going to turn into 7p. If you're unsure about why that's true, let's just talk about that for a minute. You know, with fractions, when you multiply straight across. So if I were multiplying straight across, I would do 2 times 7, which is 14. And then in the denominator, I would do 1 times 2, which is 2. And then 14 divided by 2 is 7. Why? Because those numbers were both divisible by 2. That's what happened right here. Those were both divisible by 2. I canceled them out. So I'm just kind of showing you why it works the way that it works. Now let's go back to the problem because I have to continue to distribute the 2. So 2 times this minus 1 turns into a minus 2. Over here, I'm also distributing. 2 times 2p is 4p. And then 2 times that plus 5 turns that into a plus 10. So notice in this first step, when I multiplied both sides by 2, I got rid of the fractions. Now the problem doesn't look so scary. So I have variables on both sides. I'm going to move the smaller one. So 4p, how do I get rid of it? I'm going to subtract it. So I'm subtracting 4p from both sides. So 7p minus 4p is 3p. Bring down the minus 2. Bring down the equal sign. And then on the right hand side, I'm going to bring down that positive 10. All right, now I'm looking for addition or subtraction. I see subtraction. I'm going to undo it with addition. So I'm adding 2 to each side. So now I have 3p equals 10 plus 2 turns into 12. And here is multiplication, joining the 3 and the p together. We're going to get rid of that 3 by division. And I'm going to end up with p equals 4. So just throwing that out there that you can do this problem by getting rid of those fractions. Now, if you didn't want to do it that way, you'd have to deal with fractions probably the majority of the way through that problem. So I'm really encouraging you to try it this way. And we're going to try another one together this way too. So let's look at number 8. Now number 8 looks a little bit different because there's more than one fraction. So let's look at all those denominators. We have a 3, we have a 5, we have a 10. So my question would be, okay, what would be the common denominator? In other words, what's a number that 3 and 5 and 10 can all divide into evenly, and that would be 30. Now 60 would work too, but I'm going to use 30 because it's the smallest number that all three of those would divide into evenly. So that's the number I'm going to multiply on each side. Now remember in the last problem, I didn't have to do that because I only had one denominator. But if you have multiple denominators that are different, you want to find out what that common denominator would be. If you were going to continue to use fractions, you'd have to find a common denominator. So we're just going to get rid of it. So I'm going to take this 30 and I'm going to distribute it. Now remember, I'm going to show you why this works. So I'm going to start off by doing 30 times 2/3. So if I multiplied straight across, let's say I put that 30 over 1, I would have 30 times 2, which is 60, 1 times 3, which is 3, and 60 divided by 3 is 20. Or the other way you can do it, if you feel comfortable with cross-canceling, and I would encourage you to try, is 3 divides into 30 10 times. That leaves me with 10 times 2. That takes me straight to 20. So back over here, now I have 20W. That's from right here, doing 30 times 2/3 plus. All right, now I'm going to do 30 times 1/5. Again, I can put that 30 over 1. If you want to multiply across, we can do that. 30 times 1 is 30. 1 times 5 is 5. And then 30 divided by 5 is 6. So this is going to turn into a plus 6. On the right-hand side, I'm still distributing a 30. So 2W times 30 turns into 60W. Then bring down that minus sign. Now I'm going to do 30 times 3/10. Again, I'm going to put that 30 over 1. All right, remember, you can multiply straight across and reduce, but I'm going to try that cross-canceling thing. 10 goes into 30 3 times. That leaves me with 3 times 3, which is 9. So this is going to turn into a minus 9. Fractions are gone. Isn't that fantastic? All right, so I've got variables on both sides. The smaller one is 20. Let's move it. How do we do that? We're going to subtract it. So I'm going to subtract 20W on each side. I'm going to be left with a positive 6 equals 40W minus 9. Next thing I'm going to do, I'm looking for addition or subtraction. I see subtraction. I'm going to get rid of it using addition. So I'm adding 9 to each side. 6 plus 9 is 15. So now I have 15 equals 40W. Last thing I want to do is get W by itself. There's multiplication happening between the 40 and the W. So I'm going to undo it with division. Right? Now, we know that 40 can't go into 15 because 40 is too big. So we're going to reduce. What's the number that can go into both 15 and 40? If you said 5, you're right. I'm just going to reduce those. So 15 divided by 5 is 3, and 40 divided by 5 is 8, and my final answer is W equals 3/8. Hopefully you're feeling a little bit more comfortable with those fractions. What I'd like to do for today is we're actually going to just stop there for today, and tomorrow on Tuesday we will pick up with finishing those notes, but I feel like that's plenty for us to get started with in this section. So I will see y'all tomorrow for the second part of the notes.